Okay, let's talk about the labs that are due tomorrow. So you are to do two labs. One is on EKG, where you will analyze an EKG. Remember, an EKG gives you your P, Q, R, S, and T wave. Okay, P, Q, R, S, T wave. And here we'll show you two EKG strips, one from resting and one after exercise. And we're asking you to label the EKG for the resting one. Okay, label the different waves, the P wave, the QRS wave, the T wave, and some other segments which are in the lab. Label them there. And then we ask you to analyze them for a few things, okay? So there's something called the 5 cardinal rules of EKG, where the rhythm has to be regular, meaning from R, say, from R to R. That's the time from one R to the next R should be the same consecutively. That's being rhythmic, having rhythm there. So you can measure the R to R intervals for several EKG segments and see if it's regular, even for exercise as well as before exercise. That should still be regular, even if it's shorter and faster, it should still be regular. You also asked to measure, so you can do the rhythm of these, the rhythm as R to R interval. You also do the heart rate, okay? And the heart rate you will do using what's called the 3-second method, where you measure how many R's you get over a 3-second period on your EKG strip. So you have to be able to know how to read the EKG in terms of time elapsed, okay? That's also in the lab. So you're gonna measure how many R's you get in 3 seconds and multiply that by 20, or you can do the 6-second method as well, where you multiply how many R's you get over 6 seconds and multiply that by 10. And they should both give you the same value for your BPMs, heart rate per minute, okay, beats per minute there. So that's the heart rate, and this should be in a certain range, especially if you're rested. I think from 60 to maybe 100 BPM. That's what should be a normal heart rate for a resting person. Then you ask to also measure the P to QRS ratio. This ratio, meaning for every P you see, do you also see a QRS? So you see this one is called a 1-to-1 ratio. This indicates that you have a normal SA node activity, okay? If the SA node was bad, then sometimes you will see a QRS without a P there, okay? All right, so sometimes the P wave will be absent, and so that will indicate to you that something's wrong. So for every P you see, you should see a QRS, a 1-to-1 ratio there. Then your PR interval as well, we want you to find that. That's from P, I think, to the start of Q right here. The PR interval, I think, from here to here. Not sure, but this one is also in the lab. So, and this time frame tells you how much time it takes to go from SA through the AV node, okay? And there's a certain length of time that's normal. If it's longer than normal, that means something's wrong in the conduction pathway. Something's going wrong in your heart rate. This is too slow, okay? If it's too slow, heart rate would not be fast enough. So that's also a certain range where that should be appropriate, your PR interval. And we also have your QRS interval. We asked for that as well. That one measures how much time it takes for the ventricles to become fully depolarized, meaning how long it takes to spread from the AV node through your Purkinje fibers. So again, and we have in the lab, in the table, it tells you what the normal times are. And so we want to see, when you measure these various things, are they within normal? And if not, you should discuss that. Okay, at least state that it's not within your typical 5 cardinal rules. All right, so And then, so we're gonna do before exercise, after exercise, measure these things and assess them. I think the table required, okay? And on your lab quiz, I will give you the same strips and have you assess the strips for different things. So be able to look at the EKG, label things, and measure different intervals on it. All right, and have an idea of what is going on with EKG as it changes from, say, normal and when it becomes abnormal, what's going on there. Okay, so that's the EKG lab. Then for your blood pressure lab, this one, we're gonna look at blood pressure and heart rate at rest and exercise and after exercise. So first, we're gonna look at your blood pressure, right, and the heart rate. So we're gonna first look at it in terms of position of the body. Okay, so we're gonna assess for these when you are lying down, when you're sitting, and when you're standing. We want to see if these change, okay, as you say go from this to this to this. Normally we measure your normal blood pressure is measured while sitting. That's usually when we measure it. Okay, so that's normal for us. So when you lie down, we want to see if it goes up or goes down. And when you stand up, we want to see if it goes up or goes down. So look for those trends there. So for BP, we're going to go measure SP, DP, and then you ask it to also create MAP, mean arterial pressure, of course, which you know is 1/3 PP plus DP. You use MAP, and then heart rate. Okay. So we want to see how these things occur. All right. Now, from sitting to standing, here, these should drop. SP will drop, DP will drop, heart rate will increase. Okay, and the reason why heart rate will increase, but heart rate is, the job of the heart rate is to get BP back to normal. Okay, so if it drops, it goes faster to push more blood back into the blood to pump it back up. Now, why does it drop? It drops here because as you stand up, gravity will affect your veins, and so the what's called the venous return to the heart is less. So you have less blood come back to the heart slower, which affects the output. So then your cardiac output is also decreased. And if you have less blood going into the blood vessels, that will cause your BP to drop, okay? So this is the reason why gravity will drop your BP. Gravity slows down the return of blood to the veins, to your vena cavas, into the right atrium, which means you have less blood in the heart to push out. So which means your SV is lower. And if your SV is lower, that means your CO is lower, which then causes a lower BP there. And lying down, here is the trend is, I guess, without gravity in play, then the pressure, the return is faster while lying down versus sitting up. Same idea here. So here, your VR goes up. There, VR goes up and CO also goes up. And now your blood pressure is above where you want it to be, and then your heart rate will all of a sudden drop in order to bring it back to normal. Okay, so we want to see these things occurring in terms of your changes in your body position. Let me ask you to look at these same things on the three conditions. Well, so from minute 1 to minute 5, you're resting. We're going to measure these things each minute for 5 minutes. Measure your, again, SP, DP, and HR. Measure those. And then for the next 5 minutes, do exercise. So from minute 6 to minute 10, exercising, measure again. And then from minute 11 through minute 15, you're recovering, measure again. So it's a table, all right? Of course, we already did this for you. So we already populated the table for you. But this is what we did. This is what it's based on, the idea of 15 minutes straight of measuring, resting for 5 minutes, exercising for 5 minutes, and then resting again, recovery. We want to see again how these change. What you should see is that as you work out and you demand more blood flow to your tissues in order to get rid of the CO2 and bring in fresh oxygen, here again, you're going to increase your blood pressure to push blood to your tissues faster. So BP will go up, especially during exercise. You should go up here, right? Go up, and this goes up as well. Everything goes up because it's appropriate. You're trying to get it up. And the reason why these go up is because this is going up, by the way. This comes from this. When this goes up, this goes up. And then during your recovery state, this will go down, okay? Because again, here you have less demand for it. And so you actually slow down your blood flow back to normal. It's when your power takes over or your sympathy decreases, and then these values will drop back down. It's basically during your recovery state. So again, we actually create, look at your table, analyze it, and then give us a graph, say from minute 1 through minute 15, where you're giving us heart rates and blood pressure. For blood pressure, you're just doing basically giving us the MAP, okay? So that's what you'll graph. And MAP is critical. This tells you what's the average, its value tells you whether or not you have enough pressure in your blood vessels to get the blood to your tissue. Perfusion, if it's too low, it's not getting there. If it's too high, it's also a problem. You may blow out your capillaries, blow out your blood vessels, all right? So I think that's all we want from the lab. Okay. Again, the lab quiz here on the blood pressure part, we again discuss what should have happened, theoretically, or what's happened based on the data, and how you calculate MAP based on the SP and DP values, okay, and some reasonings as to why these values change. And also, I think that you're also required to do a feedback table in terms of stimulus, detector, integrator, effector, and end results. Make sure you do it properly. I've seen some of your lab reports already where you got everything all wrong. Okay, the integrator for blood pressure and heart rate, all that stuff is not in the hypothalamus. It's in the medulla oblongata, right? In your cardiac center and your vasomotor center. This is also on your exam. So hopefully you're clear on how to fill that table out and know where what the proper answers are for the different things I may ask you. Okay, that's it.